doesn't have know how to find the square root button on your calculator, most of your calculator, the square root button, you have to either hit shift and x square or hit second and x square to give you that square root symbol. Okay, if you have problem with your calculator or don't know how to use this, send me an email or let me know and I can show you. But let's take a look at sample B. Sample B is a little bit harder. Why? Because sample B, looking at this thing here, and again, I purposely do this. Well, first of all, before we do sample B, let me ask you guys who question here. Sorry, I say we do this problem and I take any question. Any question on the 6 steps, how to find your standard sample standard deviation here? All right, let's continue, which is again, let's take a look at sample B, right? And again, I purposely make this sample B, or I purposely take this problem because if you take sample B and you find the mean is the same 78. Okay, if you remember sample A, what is my mean? I add them up and divide by 6. Same thing goes sample B. I take each of this data, I add them up and divide by 6. I have 78, and I purposely make that we have the same mean. Okay, not all the time you have your data have the same mean, but again, I purposely make it have the same mean so that I can ask you the follow-up question later. But again, looking at this thing here, step 1, same idea, right? We need to find a mean. So again, step 2, what do we need to do? Which is step 2, we need to find the deviation, right? So what is my deviation, which is my deviation here? And again, why do I say B is harder? Because when you subtract this, 40 subtract 78, you get a negative 38. And 44 subtract 78, you have a negative 34. Meaning your number is kind of humongously big compared to sample A, right? Sample A, your number is like negative 5, negative 3, 1, right? This one, you have negative 38, negative 34, 14, 16, 20, and 22. So same idea go, right? If you were to add this, which is this thing here, negative 38 and a negative 34, that would give you negative 72. If you add this is 14 and 16, that's 30. 30 plus 20, that's 50. And 50 plus 22 will give you 72. Everybody see that negative 72 and a positive 72, they will be equal to 0. So right now, everybody see that the summation, if you add all of your deviation, is equal to 0. And again, that's just tell you that at step 2, the summation, if you add all this thing up, it's got to be equal to 0. It doesn't have anything unique in terms of that. Okay. So now, step 3, what do we need to do? Which is, again, we have to somehow find a way to get rid of this negative number. So to do that, the only way that we got is we need to take them and square them. And again, this is why sample B is a little bit challenged or you know, tedious, more tedious because of the number is humongously big when you multiply itself, right? Negative 38 times negative 38 will give you a positive 1444, 1444. Negative 34 times negative 34 will give you 1156. And again, so on and so forth, which is, this is what we have. So everybody see that step 3, that's what we have here, which is, again, we take the result of step 2, we square them up. And once we square them up, what is step 4? Which is step 4, we need to add every single number in terms of step 3. Whatever the result in step 3, we need to add them up, which is if you add the 1444 plus 1156 plus 169 plus 256 plus 400 plus 484, you get 3936. And once you have 3936, what does step 5 tell us to do? We need to take this number and divide it by n minus 1. And again, if you take this number, divide n minus 1, which is the same as before, which is 6 minus 1, which is 5. And if you divide this, you have 787.2. And again, like I mentioned, this is your variance, right? If they ask you for the variance, this is the number you plug in. And again, to finish our answer, what do we need to do? To finish our answer, we need to take this variance and we need to square root it, right? We need to take this variance and square root, which is we have 28.06. Depend on your Alex, how many decimal they want it to be. I think most of them, they want 2 decimal places. I can be wrong. So just make sure that on Alex, if they ask you for 3, you give them 3. I think it's like 2.05 something or 2.062, something like that. I forgot the number, but I just kept 2 decimal places. Okay? So again, 28.06. So here comes the question I have for you guys. Well, first of all, question with this problem here. Let's go back to the sample A and sample B. So if to remind ourselves, this is the 2 standard deviation we have, right? Sample A, the standard deviation is 3.74. Sample B, the standard deviation is 28.6. So my question to you, if you don't have a question for me, is why does the 2 sample have a different standard deviation when the mean is the same? Right? As you can see, the mean for sample A is 7.8. The mean is for sample B is the same, but the standard deviation are one is so small and one is so big compared to the 2. Right? One is 3 and the other one is 28. So why does the standard deviation is so different among the 2 data? Any idea? So one thing is reminder, like, and that's this is the point that I want to pick this thing here is the mean does not justify your standard deviation. Okay, the mean is just basically the number that we want to see how far away from the mean. So the mean does not justify how big or how small your standard deviation is, right? So
Mr. Tran, the 6 minus 1 under the variance equals deviation, you get that 6 minus 1 from the n minus 1?
yes. And the n is the total number of data.
Oh, the n is okay. All right.
Yeah, we have 6 total data here, so that's where the 6 came from. Last time, the first example, I have 9 because I have 9 different data. So the n is the total, each individual data. So again, here you can see that we have 6 different, like 40 is 1, 44 is 2, so on and so forth. So we have 6. So that's why the 6 came in play.
Okay, gotcha. Thank you.
So to go back to the standard deviation, reminder or the purpose of this example is the mean, like I mentioned, the mean does not dictate your standard deviation, ladies and gentlemen. The range does. As you can see, look at sample A. Sample A, all of your data are cluttered together, right? All of your data, the range of your data, sample A is 83 minus 73. That's 10 units apart. From the smallest data to the biggest data, there's only 10 units apart, meaning all of your data kind of clutter together. Like all of them is together in terms of that. But now sample B, as you can see, the highest data is 100 minus 40. There are 60 unit separation between the smallest data to the bigger data, meaning they are spread out a lot. And the bigger the spread of your data, if they spread out a lot, then we can see that